Hi all. Let's have a look at this question. A machine has two components, both of which have independent exponentially distributed times to failure. The parameters of these exponential distributions are 0.05 per hour, 0.04 per hour. What is the mean time to failure for the machine? The probability density function of a exponentially distributed random variable is given as f of x equals to lambda times e power minus lambda x for all x greater than or equals to 0, and it is equals to 0 for all x less than 0. This is a probability density function for exponentially distributed random variable. In this function, lambda denotes rate parameter, and in the problem it is given as lambda 1 equals to 0.05 per hour, lambda 2 equals to 0.04 per hour. These are the two rate parameters for two components in the machine. Now we need to find mean time to failure. Mean in the exponential distribution mu is given as 1 by lambda. So by using this, mu1 is equals to 1 by lambda 1, that is equals to 1 by 0.05, which yields 20. Mu2 is equals to 1 by lambda 2, that is equals to 1 by 0.04, that is equals to 25. Mu1 and mu2 are the individual mean times for the components of the machine. Now we need to find the mean time to failure for the machine itself, mu machine, which is given as 1 by mu machine equals to 1 by mu1 plus 1 by mu2, which yields mu machine is equals to mu1 mu2 divided by mu1 plus mu2, that is equals to 25 times 20 divided by 25 plus 20, that is equals to 25 times 20 divided by 45. 5 9s are 5 5s are. Mu machine is equals to 100 by 9, which yields 11.11 hours. So the correct answer is option C, 11.11 hours, which is the mean time to failure for the machine.